I am incredibly excited. I am sitting here with Kingsum. He's from Alibaba. We're going to talk a little bit about performance and what it means for that business. Talking about business, you guys, at your busiest during the year, are doing $18 billion in a day in sales, which is a little bit higher than what we do in the U.S., which I think you told me is around $12 billion. So, how are you getting that done?
Well, we run our businesses predominantly on Java applications, and we scale Java applications to many servers. We're talking about hundreds of thousands of servers. And the way we do that is to customize OpenJDK and to take advantage of the open source platform, and we added some of the optimizations we need to do, and then we run our own Java applications on top of that. So this support our e-commerce businesses.
So, with that sheer volume, so how does performance really play into the business at Alibaba?
Yeah, so when you look at the scale of the systems we have, like the hundreds of thousands of servers, a 1% performance gain is a few thousand servers. Mm-hmm. So we take performance analysis very seriously.
Mm-hmm. So, you're talking about performance, you're talking about, I'm a young engineer, I'm interested in the field. How do I get started? How do I even get into space?
This is a very good question. Right now, when I look at the U.S. education system, from elementary school to the college, right? It seems that students learn from a specific domain and then they come out of college. What we need in our business is people that have multiple disciplines to work on performance analysis. Because performance analysis is not just about one field. It's not just about computer architecture, not just about software engineering, not just about statistics. We need to put these things together. So what I have observed in the past is we don't have a lot of students that have multiple disciplines like what I described. So I got interested in something called the Robotics Competition Program pioneered by Dean Kamen. Now, through volunteering and coaching robotics teams, I can observe how students learn about technologies. In fact, some of them even took classes from the free online classes like Coursera and Udacity, and they learn about machine learning, they learn about statistics, because some of those classes are not taught in their high schools. So they pick up the materials, and then they have hands-on experience with 3D printers. They put things together. So this is a very good way to encourage students to think how to combine multiple disciplines to get things to work. I think they will be great scientists, great engineers, and more importantly, great performance engineers for us.
So the high school students are teaching you how to be a great performance engineer.
Exactly.
Wow. So let's talk a little bit more about your background, because I think you, in many ways, model a lot of those high school students in terms of your, what you, from a hardware standpoint, from a software standpoint, and what that has allowed you to work at, one of the largest companies in the world, dealing with massive amounts of traffic.
Yes, indeed. My history is rather interesting as well. I started learning chemistry. In fact, I got a master's degree in analytical chemistry. So I picked up a lot of math and analysis skills there. Then I studied software engineering in computer science. I got a PhD there. Then Intel acquired me to do CPU performance. So throughout my life, I have some experience with math, some experience with CPU, and some experience with software. Mm-hmm. And it turns out that these three disciplines help me to do my job as a performance engineer right now in Alibaba.
So hardware, software, and math.
Yes.
Data analytics, understand what's happening on the actual servers themselves, and actually being able to optimize code. All of that's required.
Yes.
Wow. So that's a little different than the way a lot of people approach performance. But my experience has been a lot of folks kind of get real fixated on maybe say braking systems, monitoring the system, allocating hardware to the system, but not necessarily understanding that end-to-end view. Mm-hmm. It appears to me you're advocating for being able to have all those components together so that you can really deliver performance.
Exactly. So like you said, right, in order to optimize performance, we need to monitor and obtain performance data from the systems in the data centers. And Not only that, my chemistry background teaches me a lot about all data have errors. And so what is the difference in the mindset between people from chemistry is we assume data should have errors. And computer scientists doing simulations, they assume data is accurate. So there are some differences in the mindsets, but no matter what, we need to put our skills into good use. And like you said, right, combining software and hardware, end-to-end performance, and figure out where the bottleneck is. And more importantly, we are also evaluating new technologies in hardware or software. So we fix our goal on we want to do as many transactions as possible using as few resources as possible. And newer hardware and software technologies do come in handy.
Cool. Well, Kingsum, I truly appreciate the time today. I think you've given us a quick flavor for just how complex this field is, but yet how critical it is to the business. I mean, if you're talking about $18 billion, you're talking about 1% improvement is thousands of servers. I mean, that's a pretty important role in the organization. So, thank you.
Thank you for your time, Captain.
All right.